let's say, the last session where we introduce new material. Um, so it's about factorial experiments, and of course I won't say much about it today, but you will all find all the material um, in the places where you found the other ones. I have again an introductory PowerPoint that sets the scene more or less, so gives the bigger picture, and then you have in the Markdown, I've added an 11th chapter, so it's a completely new chapter. If you downloaded the HTML or you've put it somewhere else, uh, be aware there's an 11th chapter now dealing only with factorial experiments. Um, Now, factorial experiments is a very big subject, so it's impossible to deal with it in one single session. So I just scratch at the surface. I only explain what it is, and I try to explain how the analysis of very simple experiments can be done. Um, but it's such a big world on its own that VIB decided to organize a course that is dealing only with factorial experiments. And uh, it's, I mean, it should have taken place right now at this moment, I guess, or I mean, a real live version. So that is not taking place, and I suppose they're going to postpone it in the to the autumn or the winter of this year still. So check out the VIB, um, the VIB. Oh, I get indications that the quality of the sound would be bad. Is that true? Do you hear me properly, or do I have to do something about the sound?
Yeah, sometimes it hears like it's cut in between.
Okay, let's okay. I'm quickly gonna log out. I hope that you will be all staying in when I log out, but I'm gonna change to another Wi-Fi. Just a second. Let's hope that it keeps my connection here. Okay. Am I back?
Yes.
And it's better?
Yes.
Yeah. Okay. Um, Good. Let's hope it works. And I don't know how I can get rid of these. Okay. Um, so I hope you heard everything I said. So it's about a special course on factorial experiments that will take place in fall or winter of this year still, I suppose. So it has been postponed from um, May till, yeah, I don't know. I don't think there's a date yet. So check out the VIB website. So, but that it's all about what you can expect in next week. For this week, I would like to go over the material that you had or had gone through in the last 2 weeks about blocking and about optimal designs. And I would also like to remind you about the student cases that we would like to deal with in the next week and the week after. And I've got already a very interesting case sent in by Barbara and Lisa, and it's so elaborate even that we could spend an entire session on it. So yeah, there's lots of aspects that could trigger our attention. Um, and that case is already on the box, and I'll show it to you after we've gone through part one. There's also Victor. Victor is not online today. Send in a case, but that was so far off of what we have been discussing in this course that I don't think it would be useful to go over that case. Now, Francisco, you send also in a case, or at least a question, that was about factorial experiments, and it would probably fit in very well with what you will have to go through this week. So, Francisco, I still give you a chance of still entering as an official case. It doesn't have to be as elaborate as Barbara's and Lisa's, but I mean, just a few questions that we could ask to the entire group would be already interesting. Okay.
Okay.
So that was my introduction of today, and then I would like to, well, first give the floor to you to hear if there was any remarks or questions about uh, yeah the subject of last week, blocking and optimal design, and I also would like to reiterate on some of these aspects that were hopefully clearly explained in the markdown, but which I don't think I've ever talked about it, and I think it's a couple of important principles that were mentioned there. But I'll first give the floor to you to see if there were any specific questions about these topics.
I have one, but it's mainly due to the LMER function in R in the
Yeah.
point 10 analysis of blocked experiments. When you fit mod LMER 1.3, the final part has one vertical slash room forward slash cage. And it's the first time I saw that way of specifying a nested random effect, I would say. And I was wondering if, which kind of nomenclatures are typically used in these kind of designs. Are there more, like the one is always there, or could we have sometimes as well room vertical slash cage, or that kind of question?
Okay. Um, that is a very technical question. It's about the analysis of mixed models, and for that you would have to understand, and maybe you understand, but maybe not everybody is aware of these mixed models and what they can do. So what I have been explaining in the markdown until now, and also in the very first markdown that was really dealing with linear models, I only use these simple cases where in the random term there's a one up front, and then after the what we well, yeah we call it this vertical bar, so the pipe. Um, so what is on the right side of that pipe, that is what I have been changing until now. So the left side always had been one. So from my explanation, you can understand that yes, there are possibilities of putting something else in front of the pipe. Um, but I don't know if it makes sense to try to explain why it is. It is not so often that you will need it. yeah, 95% of the cases you can keep a one there, and you only need something to do at the end. Um, and at the end, it's typically how the uh, blocks, yeah, or other random effects are entered. Um, and now I have room slash cage. That means in this case that each cage is inside a room. Yeah, so it's just the hierarchy of the blocking effects which is indicated there. Now this LMER function is clever enough to find out that on herself. Yeah, so she is able to find out. I think functions are female. I don't know why, but so she is able to find out that cages are within rooms. Um, at least if I have done um, my coding properly. Yeah. Now I haven't done so. Let me see now. So you see that room one has a cage one, and you don't see everything, but you could think that when I have room two, you would also would have a cage one and a cage two and a cage three. Yeah, and room five would also have a cage one and a cage two. Now those are obviously different cages. Those cages have nothing to do with each other. So if I would have called them cage 24 and 26 and 27, so if I would continue uh, uh, giving different names to these cages so that those cages would be individual cages, um, the LMER function would be able to find out, oh, apparently cage 24 is always in room 1 and cage 26 is always in room 7. Then it will be able to find out the hierarchy. If I'm so lazy to call everything cage 1, or no, have a cage 1 in room 1, but also have a cage 1 in room 2, I have to indicate that it is actually not the same cage that is spread over different rooms. Um, now, we understand that a cage should be in a room. Yeah, you cannot have a cage that is in two rooms, but you could have situations where actually there is not a hierarchy, but it's a real nesting. So there is a real um, uh, two blocking effects that are over different rooms. For example, you could have a time, a week, for instance, or a month. You could imagine that you could have in the same month several cages, but the same cage could come back in an other month, because you are reusing the same cage. Yeah, in that situation, you would have not a nested um, situation, and then you would have, and I'm going to try to where can I'm going to wait a minute. Yeah, so you would have, I suppose you see my R now.
Yes,
Yeah,
yes.
so you would have, instead of one, and I'm going to make it a little bigger so that you see better what I'm doing. So now you have one uh, room cage. Yeah, room. And in this case, the cage is nested inside the room. If I would have uh, a non-nesting, like for example with month, like I said, then you would have it simply like this. So month plus cage. Yeah, so that's the way how you indicate to LMER that in this situation cage is inside the room, and here the same cages are reused over different months. Now, all this would be not necessary if I would have properly named my cages. If I call them cage one and it's actually the same cage, then it would have found out however I have been coding this. Yeah, it's not because it's now only because I'm lazy and I called cage one several times, although it's about different cages, that I have to use this notation. And to give you a small explanation on what this thing is up front is um, these random effects are used to give a yeah, and that's part of the thing that I wanted to explain later. It's to indicate that you having one single population of rooms and one single population of cages. Yeah, if you put something in front, it's actually to indicate, well, among rooms you have different types or you have different yeah, don't put them all on one heap. But that's a very technical issue, and I don't want to go too deep into that to not confuse you even further. I don't know if that's an explanation.
Yeah, it's clear now.
Okay.
Thanks.
Was there any other question? So, yeah, no,
Joris,
yes.
actually, in your R is now that function of t k2 and then multiplied by m1 and where is that t? What does it do? And
Where?
it's really in your R studio now, I think.
Ah,
If you,
okay.
well, it was in the script as well, but I think it's easier to find that right above
Okay,
the room.
right here. A T. A T is just so a K2 here is a matrix. Yeah.
Mhm.
And so if I type in K2, I don't know what K2 is, but it is a matrix. It's contrast matrix of one line. If I do T K2, I just have the transpose, which doesn't show very well. Wait a minute. I'll make another matrix. Um, uh, 1, 2, 6, and row is 3. Yeah. Oops. Sorry. So I have a matrix which should be clearer, a matrix of 2 columns and 3 rows. If I have 2 I have the transpose. Yeah. So it's just switching columns and rows.
And then the rest of the function
Oh,
where you use this M3 and
okay.
how do you get to it? I could follow every single, yeah, the where is M3 and where is contrast matrix
Yes.
from, but then the whole three things together, that's, yeah, how do we get to them?
Okay. So that's a little, well, a little, not a little. Yeah, that's just matrix algebra, and it's multiplying two matrices. Yeah, and therefore you like in this case, because um, I don't know if they're gonna be there. Okay, so M3 is the matrix that is coming from your model. So it's your model matrix. Yeah. Um, I hope you remember the example. It's about chicken feed, and you have 5 suppliers of chicken feeds. And so the model, and maybe it is still there indeed. Yeah. So you have the model that is the weight of the chicken and modeled by the supplier. So this model matrix is coming well, not straight. from that model, it's actually the variance covariance matrix of that. Okay, I think I explained, or maybe I didn't. I should check. I think I did. In the very first Markdown, so where I explained linear models, I think this is explained in detail. So go back to uh, uh, that Markdown. But what I so this is a model. Yeah, I have my model here. Um, I can extract the matrix model, the model matrix. Now, what is the model matrix? The model matrix is something. It's going to be big. Yeah. So I'm not going to be able to show you everything of this model matrix, but it looks like this. It has 22 rows, which is corresponding to the 22 cages. Yeah. So we had 22 cages in this. Um, this is a simplified example. So we have put we had a mean weight for this 4 chicken in one cage. We pull them all together, so we have one weight per cage. So we have 22 observations. So the model matrix is really the matrix that tells you how the data fits together. So there's 22 cages, and for every cage, it is indicated. For instance, here, cage 2 belongs to supplier our 104. Yeah, cage 6 is LG22. Yeah? And then you have this intercept, which is a bit awkward. This is because we model compared to I don't know which supplier that is, but the first supplier in the alphabet, probably. Yeah. So this is the model matrix is nothing special. It only tells the model of where each cage or which cage got which feed. Yeah, it's nothing more than that. In more complex models, there will be in this model matrix things for blocks or for other factors or whatever. In this case, it is very simple. It's the 5 suppliers that are here, and you have the 22 cages. Now that one, wait a minute. Okay. Um, this this model matrix is then made square, yeah, which is maybe an difficult thing to understand. You can always run the parts of the but if I do this, you get an idea of how what sort of information is in that data set. Yeah. So I have, you see 4 cages for supplier 2. So I will have 4 data points to say something about supplier 2. But if I want to make I will also have directly a comparison with the intercept, which is again supplier 1, whatever that is. And I will have also 4 data points there. Not really data points, but information points. Yeah, there's 2 feeds where we have 5 cages, so we have a little bit more. And for the intercept, we have more information. Again, bit difficult to understand, but it basically it is summarizing what is happening here in this matrix. And then this solve is just inversing. Yeah, solve is the inverse. Yeah, so in normal matrix algebra, it's -1 at the top in the as an exponent. But in R, solve is inversing that matrix. It's like a -1, and that's what we get in this M1, which is again very similar as what we had here. Like I said, it's sort of the inverse. Yeah, so you will have a a bigger number. Sorry, you will have a bigger number where we had this 5 here. Yeah. You have an awkward number here, which I also wouldn't try to explain right now. But you see also that now we took properly care of these minuses of this intercept, which is actually a contrast with this. Now, I think this is very technical. There's no need to know all this. And then this what I'm doing here is this information matrix. Yeah, I multiply with a contrast because I want to make particular contrasts within this matrix, and therefore I say, well, I don't care about this 5, this 3, 4, and 5. So just put them at 0. I don't care. I don't need them. Yeah. Um, just give me the first two, and give me make a con. I could have put them the other way around. I wouldn't have made a difference. Only the final sign of my coefficients would be different, but all variance components would remain the same. Standard errors would remain the same, so there's no issue there. But this is the only thing it does. It says, well, from this matrix, only pay attention to part of it, and then make a particular comparison to uh, to 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 those. Yeah. So if I do this, I have one single number. Yeah. Because it makes the explicit comparison here in this corner, and I have 1.25, which doesn't mean much, but it's the relative value of this against something else that tells you which one is the more interesting design. Don't worry about the technical mathematical subjects. Um, the, the point I want to make here is that realize that there is a possibility, and if you can't do it yourself, well, ask help for somebody, or if you really need it, go a little deeper, or if you don't understand it, don't bother, just do it. And I hope I explain. If I didn't explain very well in the markdown, maybe I should adapt to the markdown. But this is basically a contrast that tells you, well, compare this intercept with another one. Yeah, nothing more than that. And this is matrix algebra. Yeah, it's to multiply two matrices of different dimensions, you have to multiply with the transpose and the matrix itself. A bit awkward, but that's matrix algebra. We're not gonna explain the matrix algebra here. Is that helpful, or?
Yes, it explains some things. Thank you.
Okay. Any more questions? So again, and I think I have been saying this already a couple of times. Um, it looks like this is very technical, and you have to really know R to get somewhere in for experimental design. That is that is true, but I what I want to explain also is that experimental design can you can do lots of things up front. You can do lots of things before you actually start an experiment and avoid that you are doing bad experiments. Now you should not be aware of all little technique and all details of R code that is available. Just like if you do an experiment, you probably not familiar with all the fine details of what's happening in an HPLC machine, or you're not familiar with everything that is happening inside a RNA-seq machine. Um, the only thing you know, there exists something as an HPLC, and there exists something as an RNA-seq machine, and I can find somebody who can help me when I need such a thing. Yeah, you only have to be aware that exists, and this can help me really a lot in this case. Yeah? So as long as you are aware of that, I hope you will be able to find somebody who can do a who can help you there. Yeah, and it's strange that people do seek help when it comes to very technical lab situations, but they don't seek help when it comes to actually preparing their experiments or analyzing their experiments. And I think it's such an it became such a complicated thing to do that you need specialists. I'm afraid we cannot explain everything. I mean, we can explain everything, but we need more than a course of a few days. Then, yeah. Um, Now, I also don't want to fall in the trap of saying, well, everything is simple. Use a simple software. Use a little bit of SPSS or a little bit of Stata, and you do an ANOVA and a regression in Excel, and everything is fine. Because not everything is fine. Yeah, real life is far more complicated than what you can do in these simple things, and things can go horribly wrong in these simple softwares. So I don't want to make you or scare you off by giving all these technical details in R. I just want to indicate it's not so difficult. Maybe you can't do it yourself, but it's something which should be in reach of let a lab, or at least somebody or a couple of people should be able to do this in a lab and seek help. Yeah, because it really can improve your research. It can make your research much more efficient. And that you don't understand the matrix algebra behind it, uh, don't bother too much about it. That's not the purpose of this course. Okay. Now, like I said, there were a couple of and a couple of, and I have difficulties finding it. Yes. So you were. Let's see if I can make it also a bit clearer. So I gave you the instructions of reading chapter 8, 9, and 10 last week. And so we have this fast comparison of designs and the thing we just have been talking about of calculating determinants or model matrices and so on. So that's a bit of a, a technical aspect. Yeah. Now the, the main part that I would like to have you understood is this blocking, yeah, blocking and randomization, and how you analyze a blocked experiment. Yeah. Now, this blocking, I hope we explained well. Also in the PowerPoint, the introductory PowerPoint, it was about randomization. It was about blocking. We have been talking about blocking before. I hope that one um, um, is understood, and I hope you also understood that this technical bit here, fast comparison of designs, was actually an introduction to what I call here blocking in practice, finding these designs. Yeah? Because there is this stuff here, which you were supposed to. Well, I don't know if I and you don't have to do it for me, but the things that was done here behind the scenes is actually a automated thing of what you have been doing here with this model matrices. Yeah. Actually, I have been doing this. You see, this is this T, the small T in front, and then the other X, and then the solve is this -1. I was forgotten that I actually put it in the yeah. So all this is actually just to give you a little background why we can do this sort of thing, and probably you will do this sort of thing more often than you will do this sort of thing directly. Now, I wanted to make sure that you had understood everything that I said here. Yeah, are blocks fixed or random? Is because this is an oops, I'm where I'm gone now. Okay, I think this is an important part here. This fixed and random effects is this part. Was there anything unclear or something that you would like to have explained a little more? This green box here. Yeah, no, I hope every silence means, oh yes, we understood everything. But this goes back to the very first session, where we said, do we have experiments that are uh, that are very precise? We only want to have a sort of a proof of concept and a first hint that things are working. Um, or are we in a situation where we would like to see whether our finding applies to a broader setting? And do we want to introduce variability into the system? And and this is exactly what I try to explain here with this fixed and the random effects. Random effects you will bring in because you have a population of situations where you would like to apply your finding in. If it's blocks in a very strict experiment setting, there's still little variability, of course. Yeah? But that's the idea. So the situations that you tested it over, that population that it represents, that's where your finding is applicable to, even if you haven't tested it in that particular situation. Yeah, so it is less strict than the fixed effects. Yeah, and therefore what you get here is this different type of confidence intervals. Yeah, so if you analyze your experiment as being fixed, yeah, you're gonna have very small error bars, and people like small error bars. Yeah, um, but you have to realize that it's not always because you have small error bars that you have been doing good research. Yeah? Sometimes the red error bar is the more relevant one, because you are in a stage where you would like to say, well, I have been testing a couple of things. I know there is variability in between my cages in this case. In this case, so therefore I have to um, give error bars that take that variability of these cages into account. And maybe next time I will do my research in other cages, and then I may not have the same sort of results anymore. Yeah. So this choice, whether you take something as a fixed or random effect, is really a crucial one, because you see how what a big difference this choice gives on the size of the confidence intervals. Yeah? But the
Yuri?
interpretation of things is completely different.
Yuri?
Yes,
Ah,
yes,
can I ask one thing?
yeah.
In the very final paragraph of the green box, it says that, well, you wrote that estimating a random effect on the basis of 5 or less levels is not recommended. Could you explain what these 5 actually mean? 5 fixed levels or?
Well, so if we take again this example of these cages, yeah. So we know there is well, we don't assume that this company has many cages, and farmers also have cages and whatever. So there's an immense population of cages. Yeah. Um, Now, claiming if you would do an experiment on two cages, that those two cages are representative for all these cages in the world, that is a little, yeah, far-fetched. Yeah, so it's not justified to say, well, this those two represent everything. It's impossible. Um, so we and depending on what you are studying and how variable things are and how heterogeneous things are and so on and so on and so on, um, you need more of these representations to have a good idea of how these, in this case, cages behave. Yeah. um, uh, if you would say, I would like to estimate what is the body weight of all the people in Leuven, for instance, you would not pick three people and say, oh, well, I have a good idea what the body weight of the people in Leuven is. Yeah, you need a bigger sample. Yeah. Um, and depending on what you are studying and how heterogeneous your population is, and so on and so on and so on, you will need more samples. So it's just the same as any other thing. Your sample needs to be big enough, and the same applies for these random effects. You only can claim that you have been, yeah, reasonably estimating this random effect when you have enough representatives of the entire population. Yeah, in this case, we're talking about cages, and so yeah, they're not that different from each other. They probably don't behave very heterogeneous. So 5 or 6 or 7 may be a good number already to have a good estimate of what uh, this this random effect of cages is.
Okay,
Yeah.
thank you.
Ten, 10.3 here, again, a very technical thing. Don't bother too much about it. But what I'm doing here is to explain why the blue is different from the red. Yeah, you see that in the blue there's an extra part here that is added. So this will lead into the blues. This will lead into the red. So there's this. It's exactly the same except that I have an extra part here, and that makes that they are obviously bigger. But that is the part that allows you to extrapolate to other cages. This is the cages that were inside the experiment. Yeah. Now, this way of calculating is a bit dodgy. Yeah, it's not entirely how it should be done. So, in order to cover my back and have no complaints about, yeah, this is actually not correct. Um, have added this one, which is far more complex and doesn't explain what is actually happening. So that's why concentrate on this one and don't bother about the 10.3 there. Okay. No more questions? Okay, then I'll go back to the last part, and that's the cases. And I'm gonna present you already, or maybe I can give the floor to Barbara or Lisa. They both here, but I have to look for, where do I have it? Ah, maybe it's there. So in the box that we use for this course, there is session 5, so which is about factorial designs. Yeah, the introduction to factorial designs you will find here. But I also added a folder for student cases, and this is a document supplied by Barbara and Lisa, and I have the permission to show it to you or to share it with you. And there is first the text of Barbara and Lisa themselves. So this what they have sent in. We have had a couple of email conversations to straighten a couple of things out. But so this is the, let's say, the basic information that you have, and then I have added my part to it, and this the little bit more explanation of the things that wasn't in the original description, um, and I also have a couple of questions, and I would like that you at least start to think about this case. It's a very elaborate case. Well, it's not elaborate. The case is actually simple. It's not such a difficult situation. Um, yeah, it can be explained in one page. Um, but you'll see there's lots of little aspects that I haven't been covering in the past sessions, and I will take the opportunity to show you. Well, there's lots of hidden pitfalls in experimental design and in data analysis, which I haven't touched at. Yeah, and there's a couple of things that will come back, that we will have an application of things that we explained in the previous weeks, but there's also little, yeah, I call it pitfalls, that are where this example is perfect for to give you an explanation. So we will spend a little bit more time than I had foreseen on this case. just because it's so interesting, according to me. Um, so read it, and this is the questions I would like to have been answered. Now you don't have to literally answer everything. I don't. I mean, if you don't have time or you don't have the skills or whatever to actually go to the very end of making simulations and try to find out where the variance components are coming from and so on and so on and so on, don't bother. Yeah, try to at least give an honest try and try to think about these questions. Think about what you would be supposed to do, even if you don't do them in reality. That is not so important. As long as you have the principles and the important steps, if you master that, I'm already more than happy. Um, I will also have, hopefully, yeah, in the near future, I will have a talk with Barbara and Lisa to see if we can even share data with you, and then we can even take it a little further to actually calculate variance components and see a couple of the pitfalls in reality. But that we will see. We see next week after I had my talk with Barbara and Lisa. But that's it. So if you would have also an example like this, and like I said, we don't have to spend an entire session on it, like I think we will do on this case. Even if you have small little questions, uh, it's fine. So just send them in, uh, drop me an email, and I'll respond to it. Okay, is that clear? So next week we will talk about factorial designs, or at least the questions you had about factorial designs, and we will start tackling this case, and probably also, if there's other cases that were sent in, introduce those ones, and that will then be for the last session in 2 weeks. But that's everything I had to say today.
Sorry, Joris, and
Mhm.
next week, is it on Thursday or is it on the 5th, on Friday? That's again in the PowerPoint and also in the email that we got from VIB that was asking about the next is factorial design course. They also said that you have to attend the session of the 5th
Okay.
of June.
Well, that is bizarre, because I thought that the course on factorial experiments was really postponed.
I know, but they say it's postponed, but if you want to follow it, you have to follow the last two sessions of the experiment design, and they say it was 5th and 12th.
Okay, well, so
That's how was the...
yes, so this introductory session is the thing that you are supposed to prepare for next week. Yeah, so that's it actually. It's this chapter 11. I actually chapter.
The question is,
Mhm.
when will our session be? Is it on
And
Thursday, which is the 4th, or will it be on the 5th, like it says in PowerPoint and in that email?
no, it will be on Thursday morning, like always.
Okay.
And then I'll send to VIB a message that maybe they have to correct that, because I don't know to who they all sent these emails to. Um, so we have, like always, on Thursday mornings this session, and so the next session, which is then yeah, I don't know what date it is. Is it 4th then?
4th, yeah.
Yeah. So on 4th we will have the question and answer session on these factorial designs. But actually, yeah, people that join next week will have not had this preparation, so they will be a little too late if they join next week. So that's sort of miscommunication between myself and VIP, I guess. I'll send an email to. Did you receive the email from Yannick or from
Yeah, I
Joke?
got an email from Yannick. I can forward it if you want. It's online factorial design and analysis course, and they say to follow the course, you have to attend the last 2 sessions of the experiment design course on June 5th and June 12th.
Okay.
And then later more details about the factorial design.
So that those, I mean, the information is right, but the dates are wrong. Yeah.
Yeah, actually, I also asked when was going to happen the next session.
Yeah.
And I said, would it be like in June/July or will it be later? Because if it's in June, July, I cannot. And if it's later, I can. And apparently it's going to be right after this one. That's what I received from her side.
Okay. Because I
Well,
haven't.
they're
Yeah.
asking how many people are interested, and then
Exactly.
based on that, they will organize the dates, but they haven't confirmed the dates yet.
Yeah.
Exactly. I just asked, is it going to be right after this one or will it be later in the autumn? So
Okay.
they told me that later, but sorry, that now. But if it could be later, then I would join again. So that's my question as well.
Okay. Okay. Well, and you see it also with. So we started this session with, I mean, 20 people or so, because we were in the full lockdown and nobody had better things to do than attending courses. But you see, I mean, everywhere works is starting up, and it's actually quite hectic. I have the impression. So I don't think it's a good idea to have more online sessions, while I suppose, like things are going now, we will be able to have live courses. I mean, like in-person courses in after summer, and therefore I think it's preferable to do it live. Um, but I haven't heard anything from VIB to that matter, so it's surprising to me. But okay, so I don't take any information from me. I'm apparently I'm the least well informed of the whole bunch here. Yeah, I'll ask Yannick to clarify things.
Okay, thanks.
Yeah. Okay. Uh, Barbara and Lisa, would you have time to just hang on for a while? Then we have a talk. Yeah.
It's possible. Yeah, for me that's also fine.
Okay. Okay, then I would say to the others, class is finished. You can leave so that I can have, yeah, that we can continue talking with Barbara and Lisa. Talk to you next week then.
Okay, bye-bye.
Thank you.
Bye.
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 Oké. Ik vermoed dat wij Nederlands kunnen praten.
Ja, dat klopt.
Ja.